Hi, I'm Mr McTaggart. In this video we're going to be looking at writing things as ratios and therefore simplifying them as well. So ratios are used in the real world when there's a need to compare practical values. Ratios are used to determine how much of one object exists in comparison to another. And you'll be aware of ratios in real life without ever actually having been taught this before. So ratios, where are they used in everyday life? So I've got a couple of examples here. So they're used in gambling. When you place a bet on a horse, you're given odds. For example, the odds on the horse winning are 5 to 1. That means you'll get £5 for every £1 you bet. That is a ratio. Anything in maths where we're talking about sharing equally between people, sharing is done in a ratio as well. Adults to children, ratios on trips or lessons. My thinking here is whenever you have to do a school trip, you have to have a legal requirement of so many adults per children. And if you may be having swimming lessons, you might be in a group of eight children to one teacher, or you might be in a group of smaller of 4 to 1. So you might have heard it used there. And then anything to do with mixing, whether it's mixing paint, diluting juice, recipes. If you think about diluting juice, if you've ever read the back of the carton, it tells you should mix 1 part concentrate to 3 parts water, although we all don't really do it, we just kind of go roughly, don't we? Any kind of recipes. Recipes are actually a really good one because quite often you're given a recipe to make maybe 20 scones, but what happens if you want to make 40 scones? You have to double all your quantities, so that is using ratio. Okay, so on this screen I've got a couple of counters. I have got pink counters and I have got purple counters. So if I wanted to write the ratio of pink to purple, we write it as pink colon purple. But when you're saying that out loud, the colon gets said as the word to. So pink to purple is as simple as counting how many pink are there. There are 5. And how many purple are there? There is 4. Now that is the ratio of pink to purple in its most simplest form. Now if I was to do it the other way round, I could also say, well, the ratio of purple to pink therefore is 4 to 5, and it's just switching it around. But when you're reading the question, they will give you the ratio in the order they want it to be written as. So here is an example where it's in a story. So a recipe requires 450 grams of flour and 200 grams of sugar. Write the ratio of flour to sugar in its simplest form. So we start by writing flour to sugar. And then underneath each of these, we're going to write in what we've been given. So we know there are 450 grams of flour and 200 grams of sugar. So that is our ratio. But obviously if we wanted to then make a different amount of whatever this recipe made, let's say it made scones, we'd have to play around with these quantities, and we want them to be given in the same ratio. This ratio is not in its simplest form, so what I need you to do is think of fractions. If you had the fraction 200 over 450, what would you do? Well, I'd hope you maybe score off the zeros first of all to make your numbers simpler. And then you look at the 20 and the 45 and think, right, what can 20 and 45 both be divided by? Essentially finding the highest common factor. So in this case, they both divide by 5. So I'm going to score out my zeros and then I'm going to divide both my numbers by 5. Because a bit like fractions is to keep it the same equivalence, you have to divide both sides by the same thing. So this would give us 9 to 4. So there are 9 parts flour to every 4 parts sugar. So if you were putting in 4 scoops of sugar, you would put in 9 scoops of flour, and then that would always have it in the same ratio. Here's another one from a picture. So we're going to talk about length to breadth in this one. So length of this rectangle is the longer one. Think about the swimming pool. The length is the long side and the breadth is 6. So if I was wanting length to breadth, I'd write 10 to 6. Units don't matter in the ratio for your final answer, but if they are given in different units, then we have to play around with them first. So no units in my answer, it's just 10 to 6. Now they are both hopefully in the 2 times table. Do you spot that? So we're going to divide both those numbers by 2, and that will give you 5 to 3. Now with the same rectangle, I'm going to complicate it. I'm going to ask you for area to perimeter. So remember, area is length times breadth. So that is 6 times 10. So my area is 60. Perimeter is if I was walking right around this rectangle. So my perimeter would be 10 plus 6 plus 10 plus 6, whichever way you want to do that, which is 32. Now just looking at these numbers, 60 to 32 can simplify because they are both in the 2 times table. Now they might be in a times table bigger than that. If you don't spot it, you go with what you do spot, and then just appreciate you might have to take more turns. So if I go with the 2 times table here first of all and half both these numbers, I'll get 30 to 16, and then you'll maybe think, oh wait a minute, I'm not done, they're still both even numbers. So let's just try halving them again, and we get 15 to 8. Now actually what I should have done there is maybe spotted my 4 times table, but you might not have done. So it was a good wee lesson on just seeing that, like fractions, when you're simplifying fractions, you don't always get it first time. It might take you a wee bit more work. Just keep checking you can't simplify any further. So final answer for area to perimeter is 15 to 8 in its simplest form. Okay, example 4, I'm just going to practice some more complicated, very basic, let's simplify the ratio questions. So 32 and 12 are both in the 2 times table. They're both actually in the 4 times table. So for the first one, we're going to divide by 4. 32 divided by 4 is 8. 12 divided by 4 is 3. So in its simplest form, that's 8 to 3. 26 to 104. Now 26 isn't in a lot of times tables. It can divide by 2, it can divide by 13. 104 I might not recognise as well, so we're going to do that trick again. They're both even, so let's see what we're getting with half them. So if I half the 26, I get 13. If I half 104, I get 52. Now you might be sitting there thinking you're done, because nothing goes into 13 other than 13 and 1, and not a lot goes into 52. However, I'm spotting that 26 doubled was 52, so in actual fact, 52 divides by 13. So I can divide them both by 13 now, which will give me 1 to 4. So in actual fact, if you spotted it, well done. 26 times 4 was 104. So the ratio here in its simplest form is 1 to 4. And then my last one is just to show you, I mentioned about units earlier. If they weren't the same units, you have to make them the same. So I'm going to turn all these ones into pence. And it becomes 30 to 240. I can then cancel out a 0 to make my numbers easier. 3 and 24 both divide by 3, so that would give me 1 to 8. Now I can do this with anything. I can do it with grams and kilograms, litres, millilitres, centimetres and metres. But to be able to simplify, you need to convert them both into the same units first of all. So that's me done my example. All that's left now is for you to maybe pause this video and try some for yourself. So I've got 6 examples there, some from pictures, some from just simple, let's try and simplify your ratios. And remember, you might not always get there in the first try. It might take you 2 or 3 goes to simplify right down as far as possible. So pause the video, give these a try, and then unpause, and then you'll see that your answers are here, and a lot of them involved simplifying as well. So what have we learned in this video? Well, we've learned how to identify and write 2 quantities as a ratio. And we've also learned how to simplify a ratio, very like the process you would do in fractions. Now, one thing I didn't mention is I only use 2 quantities ratio. We could do it with 3 or 4 things, but that's maybe something for another day. Thanks very much and good luck.